This one is all about how materials behave depending on how their particles are arranged and how energy changes things like temperature and state. Sounds fancy, but honestly it is very doable once you break it down. First off, density. Density is defined as mass per unit volume. The formula for density is mass over volume. You can write it as D equals m over V. Now for the units, mass can be measured in kilograms, volume should be measured in cubic meters in that case, and your density is given in kilograms per cubic meter. Alternatively, you can use grams for mass and cubic centimeters for volume, and the density is given in grams per cubic centimeter. And here is an important unit conversion. 1 cubic meter is the same as 10 to the power of 6 cubic centimeters. So to convert cubic meters to cubic centimeters, you need to multiply by 10 to the power of 6. To convert cubic centimeters to cubic meters, you need to divide by 10 to the power of 6. Here is a question for you. Here is the answer. For the first part, it is very straightforward. 200 grams divided by 40 gives 5 grams per cubic centimeter. For the second part, you need to convert the mass into kilograms. So 200 divided by 1000 is 0.2 kilograms. Volume is 40 divided by 10 to the power of 6. The calculator gives 40 times 10 to the power of negative 6. Substitute in the formula, and you get 5,000 kilograms per cubic meter. It is important to note that usually solids have higher densities than liquids and gases, and usually gases have the least density. You can clearly see this in the diagram. To find the density of an object, we need to know the mass and volume. Finding the mass of an object is really easy. All you need to use is a top-pan balance. To find the volume of a regular shape, we can just use the length, width and height. For example, for a metal cube, you just multiply them together to get the volume. Now to find the volume of a sphere, the formula is 4/3 pi r cubed. So all we need is the radius, so you can use a vernier caliper to measure the diameter. Once you know the diameter, half it to get the radius. Now you can plug it in the formula 4/3 pi r cubed to get the volume. Then you need to substitute in the formula density of a liquid. Again, we need mass and volume because density equals mass over volume. So first you need to place an empty measuring cylinder on the top pan balance and reset the balance to be 0. Usually there is a tare button here. You can press it and it goes to 0. Now add 10 milliliters of the liquid, say up to this level. Now you have a volume reading and you have a mass. Divide mass by volume so you get the density. Then you add another 10 milliliters. That is 20 milliliters altogether. Now you have a new mass reading and can calculate the density. Then you need to use these density readings to calculate a mean density of an irregular object. Imagine you have an object that is shaped like this. Finding the mass is easy. All you need to use is a top pan balance and record the mass. Density equals mass over volume. To find the volume, you need to use what we call a eureka can or a displacement can. So first you need to get an empty eureka can. When you fill water, it will only go up to this level, only because any excess water will obviously flow out. Then you need to take this irregularly shaped object and tie it to a string, and you need to slowly lower it into the eureka can, and make sure to put an empty measuring cylinder here to catch any water that comes out. So the volume of water that gets collected out here is exactly equal to the volume of this object. Now, use the formula to calculate the density. There is another way to do this using just a measuring cylinder. So in this case, you need to fill water up to a known level, say V1. Let's assume this is 20 cubic centimeters. Then like before, you need to tie this irregularly shaped object to a string and slowly lower it into the measuring cylinder until it is completely submerged. The water level will go up. Now, the new volume is V2. Let's say this is 30 cubic centimeters. So obviously, the volume of the object must be the difference between V2 and V1, which is 10 cubic centimeters. Now pause the video and take a minute to have a look at the properties of the 3 states of matter. You need to know about the arrangement of particles. In solids, there is a regular pattern. In liquids, it's random. And in gases, again, random movement of particles. Solids vibrate about fixed positions, but liquid particles are free to move around each other. And in gases, particles move very quickly in all directions. In solids, particles are relatively close. Liquids are moderately spaced out, and gas particles are significantly far apart. Solids have a fixed shape. Liquids take the shape of the container. Gases have no surfaces, so there is no shape. Density of solids is high. In liquids, it's moderate and low in gases. Volume of a solid is fixed. Volume of a liquid is also fixed. In a gas, there are a lot of spaces in the middle, so it can be compressed, so it is not fixed. A solid melts to turn into a liquid, and a liquid freezes to turn into a solid. A liquid can be subjected to evaporation or vaporization to turn it into a gas. A gas can be condensed to turn into a liquid. A solid can turn into a gas directly without going through the liquid phase, and we call this sublimation. The opposite of sublimation is either desublimation or deposition, specific latent heat. Think about this experimental arrangement. You have a container in which you have ice at minus 10 degrees Celsius. You put a heater here, and then there is a temperature probe connected to a data logger and a computer to measure the temperature, and then we start to heat this. Imagine it starts from minus 10 degrees Celsius, and then the temperature increases. And when it goes to 0, something peculiar happens. Although you keep on heating, the temperature does not increase. It will remain at the same level for a little while. What is really happening here is the energy that you provide is being used to break bonds and turn the solid into a liquid. So at the beginning here, everything is solid. At the end here, everything is liquid. Now once everything is liquid, the temperature will rise again. So the liquid will heat up, and the same thing happens when it hits 100 degrees Celsius. Now the liquid is being converted into gas. Vaporization is taking place. So again, the phase change takes place, and it requires energy. So the temperature does not rise. So what happens in places like this is called a phase change. Specific latent heat is divided into two categories: specific latent heat of fusion, where a solid is turning into liquid, and specific latent heat of vaporization, where a liquid is turning into a gas. Let's take an example to understand this in depth. You have 1 kilogram of ice at 0 degrees Celsius, and you need to convert it into 1 kilogram of water at the same temperature. So you can see the temperature has not changed. Remember, the graph was flat. This process requires 334,000 joules. So the definition of specific latent heat of fusion is the amount of energy needed to convert 1 kilogram of a solid at its melting point to liquid without changing its temperature. So we can say the specific latent heat of fusion of ice is 334,000 joules per kilogram. Think about 1 kilogram of water at 100 degrees Celsius at the boiling point of water. Now if you want to convert this to steam at the same temperature, the amount of energy needed is 2,260,000 joules. So the definition of specific latent heat of vaporization is the amount of energy needed to convert 1 kilogram of a liquid at its boiling point to gas without changing its temperature. So we can say the specific latent heat of vaporization of water is 2,260,000 joules per kilogram. The formula for specific latent heat is E equals m times L. E is the energy in joules, m is the mass in kilograms, and L is the specific latent heat in joules per kilogram. And you can use the same formula for both fusion and vaporization. Here is a question for you to try. Please pause the video and give it a try. Part A is very straightforward. This is a direct substitution. E equals m times L. Mass is 0.5 kilograms. It's really important that you convert grams to kilograms, and L is given. The answer is 167,000 joules. The second part, explain why the temperature of the ice does not change during melting, even though energy is being transferred. For 1 mark, you need to mention that the temperature remains constant during the change of state. The second mark, you need to explain that energy is used to break intermolecular bonds and not to increase temperature. So in a solid, the particles are like this, very close to each other. So energy is needed to overcome the forces and turn it into a liquid. Here is your mini quiz on the particle model of matter. Please pause the video. When you are ready for the answers, press play. Here are the answers.